Good morning, students. Welcome to our session for today. We will discuss about the random variables and the probability distribution. But before that, let's have first our learning competencies. We have illustrate the random variables, either discrete and continuous, and distinguish between a discrete and a continuous random variable. And we have a random variables class. Okay, a random variable is whose possible values are determined by a chance. And a random variable is typically represented by an uppercase letter, usually the big letter S. And its corresponding lowercase letter in this case is the small letter x, is used to represent one of its values. For example, a coin is tossed twice. Let the variable x represented the number of heads that results from this experiment. So we have a coin tossed in 3 times. So we have the first toss, second toss, and the third toss. So in the first toss, we have the outcome, which is head and tail. And the second toss, we have the 2 heads and the 2 tails. And the third toss, we have 4 tail, and we have the 4 heads. And we have the final outcomes. We have the head, tail, and we have the head, tail, and we have head, tail, and we have tail, head, and we have the tail, tail, and we have tail, head, and we have the tail. And we have also the sample space. The sample space class is for the possible outcomes of an experiment. So in that last figure, we have the sample space, which is the head, and we have the head, tail, tail, and the head, tail, and we have the head, tail, and we have the tail, head, and the tail, tail, and the tail, head. And we have the last one, which is the tail. The value of the variable x can be 0, 1, 2, and 3. Then in this example of x is a random variable. So random variable class can be a discrete random variable and a continuous random variable. So first, let's discuss about a discrete random variable. Okay, a discrete random variable class, it can only take a finite countable number of a distinct values. Distinct values means class of values that are exact can be represented by a non-negative whole numbers. Okay, example. So let x be the number of students randomly selected to the interview by a researcher. So class, this statement is a discrete random variable because it is possible values are 0, 1, 2, and 3, and so on. And have another example class. So the number of points scored in the last season by a randomly selected basketball player in the PBA. So that statement class is a discrete random variables class. Yes, because its possible values are 0, 1, or 2, and so on. And another example, let y is the number of a left-handed teachers randomly selected in a faculty room. So that statement class again is a discrete random variable because its possible values class are 0, 1, and 2, and 3, and so on. That and last statement, we have let z, the number of a defective light bulbs among the randomly selected light bulbs in a particular area. So that statement class is a discrete random variable. Yes, because the number of defective light bulbs class can be which can be assumed as which is x can be assumed are 0, 1, 2, and 3, and so on. And let's have our continuous random variable class. Okay, a continuous random variable class can assume an infinite number of values in an interval between two specific values. Okay, class. This means that a continuous random variable can assume a values that can be represented not only by a non-negative number class but also a whole numbers and fractions and decimals. These values are often result of measurements. Example, let Z the hourly temperatures last Sunday. So Z is a continuous random variable class. Yes, because its values can be presented between any two given temperatures resulting from the use of a thermometer class. And have a next example. Let Y the weights of a randomly selected students in pounds. So that statement class is a continuous random variable. Yes, because its values can be between any two given weights. Also, weights are measured using a weighing scale. And the weight of a student, for example, can be 150.5 pounds, but due to limits of its measuring device, the measurement is always an approximate. So the weights of the students can range from 100 to 180 pounds, including the decimal places that come between these two values. Plus, okay, and have another example. Okay, listen. The length of randomly selected shoes of senior students in centimeter. Okay, that statement class is a continuous random variable because the lengths of the shoes of the students can be between any two given lengths. So the values can be obtained using a measuring device such as ruler. And last example class. Okay, the hourly temperature last Sunday. So it is a continuous random variable again because its values can be any between of any two numbers in resulting from the use of thermometers. And how? And that's for our continuous random variable. Now let's proceed through the activity. Try this. Okay, determine if the random variable x or y is a discrete or a continuous. First, we have x, a number of points scored in the last season by a randomly selected basketball player in the NBA. So, it is a yes. It is a discrete random variable. And now the height of a randomly selected student inside the library in centimeter. Yes, it is a continuous random variable because it is in measurement. So we have the number of birds in a nest. So it is a, yes, very good. It is a discrete random variable. Okay, y is equal to the weight in kilogram of a randomly selected dancers after taking up an aerobics. So we have a continuous random variable. And number 5, we have the number of mobile phones sold in 1 week in an AB store. So we have a discrete random variable. Next, we have the number of cars in a parking lot every noon. So it is a discrete random variable. The length of time spent in playing video games? Length of time. So we have, yes, very good. It is a continuous random variable. And now we have the height of a varsity players in your school in meters. So we have, yes, very good. It is continuous random variable. And the amount of money spent spent by a family in 1 month. So we have, yes, discrete random variable. And we have the last one, the number of books you borrowed in the library during your elementary years. It is a discrete random variable. And that's all for today's discussion. See you next week for the new topic will be discussed. And that's all. Thank you.